Hello, I'm Don Machholtz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 66 for the week of April 7th, 2021. The related website for this podcast is donmachholtz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, April 7th, the moon is a crescent in the morning sky a few degrees south of the planet Jupiter. The moon will be new, passing south of the sun on April 11th, 12th, depending upon your time zone, but April 12th, 0230 Universal Time. If you want to see the thin crescent moon in the morning sky just before it becomes new, those of you living in the southern hemisphere are favored as the ecliptic in the morning sky tilts to the south, and the moon is south of that. Those in the northern hemisphere and the equatorial areas are favored for seeing the early thin crescent moon in the western evening sky on the evenings of April 12th and 13th. By next Tuesday, the moon will be a very slim crescent in the evening sky. Mars is still in the evening sky. Can you find it? Hint, it is in the constellation Taurus, just south of Auriga. It has become quite faint compared to what it was last October, when it was 4 times closer to us, and it will continue to dim in the evening sky for the next 3 months, when it will disappear into the evening twilight. Will you be able to see the International Space Station this week, which, for our purposes, begins on Wednesday, April 7th, through Tuesday, April 13th? It all depends upon your location. This week we have 6 zones. 6 zones, why is that? Well, the International Space Station must be in sunlight while you are in darkness. And it does not sit still. It orbits the Earth every 90 minutes. All you need to know is your latitude. At 48 degrees north and north of that, you will not see the International Space Station at all. From 15 through 48 degrees north, you can see the International Space Station in the evening sky, but only for the first few days of this week. The further south you live, as you approach 15 degrees latitude, the more times you'll see it this week before it disappears from your sky. Between 10 and 15 degrees north, the ISS will be in your evening sky for only a few days, and that is midweek this week. From 10 degrees south through 10 degrees north, near the equator, the ISS will be in your evening sky beginning about halfway through the week. From 27 degrees south to 10 degrees south, the ISS will be in your morning sky beginning midweek. South of 27 degrees south, the ISS will be in your morning sky sometimes twice per night. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Now for the comets visible to us this week. We have one in the morning sky rising shortly after midnight, visible at about 9th magnitude. It is Comet C/2020 R4 Atlas, discovered September 12th, 2020 at 19th magnitude with the Atlas Sky Survey System. The comet takes about 1,000 years to orbit the sun. It is in a retrograde orbit, meaning it goes around the sun in the opposite direction as we do. It was closest to the sun on March 1st of this year, as far from the sun as we are. And now it is slowly moving away from the sun and moving closer to us. It will be about 0.46 astronomical units, or half the distance the sun is to us, on April 23rd. It is presently moving about 2 degrees per day, but it will be speeding up even beyond that. The present brightness is between magnitude 8 and 9, faintly visible in binoculars, easy in most telescopes. Podcast 66, map 3, shows the position of the comet at 0 hours universal time. Correct it for the time in your time zone as it is moving rapidly. The positions, the right ascension and declination of this comet can be found on podcast number 66, Comet Positions. You can also get the present position of this comet from heavens-above.com. Sometimes people ask me, Don, when you are comet hunting, do you ever come across a known comet and at first think that it is a new comet? Well, that happened to me with this comet on March 22nd, a couple of weeks ago. I picked up a fuzzy thing where there should be no galaxies nor clusters. My first check was to see if there were any known comets in the area. So I went to heavens-above.com on my phone and looked under comets, and there it was, Comet C 2020 R4 Atlas, right where I was looking. End of excitement. Now for the astral class. Remember when you were young and had to memorize multiplication tables such as 3 times 3 is 9 and 4 times 8 is 32? That knowledge has been helpful to you throughout life. This week, I'd like for you to learn some planet facts, things about the solar system that, if you remember, will make you a big hit around astral circles. Well, maybe not, as most who have been involved in astronomy for some time have a good knowledge of these things. But you will be able to keep up with them and talk intelligently. Let's begin with the Earth. The Earth takes 1 year, 365.25 days, which is why we have leap year, to go around the sun. It is as far away from the sun as what is commonly known as an astronomical unit. An astronomical unit, abbreviated AU, is 93 million miles or 150 million kilometers. That is the average distance from the sun to the Earth, although throughout the year it does vary by about 3%. Light takes 8 minutes to travel this distance from the sun to the Earth. And the Earth is round with a diameter of about 8,000 miles. Actually, it is 7,917 miles, but we will round it up to 8,000 for our purposes, which is about 13,000 kilometers. And the Earth rotates on its axis in 24 hours. Now for the Sun. It is 109 times the diameter of the Earth, but you can rough it out to 100 times bigger than the Earth. The sun rotates once every 27 days at its equator, its big fat equator, and it takes a few days longer for each rotation as you head towards the north or south pole of the sun. And yes, the north and south poles of the sun are very hot, not like our poles. The whole sun is hot, about 27 million degrees Fahrenheit in the center, but the surface is much cooler, about 10,000 degrees Fahrenheit, which is about 6,000 degrees Celsius. The planet closest to the sun is Mercury. It is small, about 37% the size of our Earth, or about 3,000 miles across. Mercury travels rapidly. It revolves around the Sun in 88 days. It goes around the Sun 4 times in the amount of time it takes us to go around the Sun once. Sometimes when I was teaching a class, I would say to the kids that if they lived on Mercury, they would be 4 times older than they are now, as every time the planet Mercury goes around the Sun, that is 1 year on Mercury. You would not age more quickly, you would just have more years in your age. If you could live on Mercury, you may live for 300 Mercury years, but you would not be able to drive until you were about 65 years old. Maybe you would drive a Mercury car, remember those? Mercury looks much like the moon, plenty of craters. Its day lasts 59 of our days. How far is Mercury from the Sun? Remember that the Earth is 1.0 astronomical units. Well, Mercury is only 0.4 astronomical units from the Sun. Venus is the next planet, and it is nearly the same size as our Earth, slightly smaller, but roughly the same size. Venus takes 225 days to go around the Sun once. That's a little more than 7 of our months. Its day is longer than its year. It rotates very slowly, once every 243 days, and in the opposite direction of most of the other planets. Venus is covered in clouds. It is 0.7 astronomical units from the Sun. We are the next planet out. Then comes Mars. Most people are surprised by the size of Mars. It is small, about half the size of Earth, bigger than Mercury, but smaller than all the other major planets. It takes Mars 687 of our days to go around the Sun. That's 1.9 of our years. Mars rotates once on its axis every 24 hours, 37 minutes, slightly longer than our day. It is 1.52 astronomical units from the Sun. Mars has 2 moons, both very small. Our next planet is Jupiter. It is 10 times larger than the Earth and about 10 times smaller than the Sun. It rotates fast, so fast that in a telescope you can see that the equator is wider than the poles. It rotates once every 10 hours. Jupiter takes nearly 12 years to go around the Sun once, and it's 5.2 astronomical units from the Sun. It has dozens of moons, but the 4 big ones to remember are Io, Europa, Ganymede, and Callisto. These 4 moons are visible in a small telescope. Next is Saturn, the planet with the rings. The planet, not measuring the ring, is 9 times larger than we are, almost as large as Jupiter. It takes 29.5 years to go around the Sun, and it rotates on its axis nearly as quickly as Jupiter. Saturn is 9.5 astronomical units from the Sun. It has dozens of moons, but the main moon is called Titan. We even landed a spacecraft on Titan in 2005. The next planet is Uranus, which is 4 times larger than is the Earth. Uranus was discovered in 1781, and even though it is barely visible to the unaided eye, binoculars and a small telescope show it well. It takes Uranus 17 hours to rotate once, and its axis points to near the ecliptic, so it seems to rotate on its side. It takes Uranus 84 years to go around the Sun, and it is 19 astronomical units from the Sun. Finally, we get to Neptune, which was discovered in 1846. Like Uranus, Neptune is about 4 times the size of the Earth. Neptune takes 165 years to go around the Sun, and it's 30 astronomical units from the Sun. So there are a few things to memorize about these planets. For instance, what do these numbers mean? 88 days, 225 days, 365 days, 687 days, 12 years, 29.5 years, 84 years, and 165 years. That is the time it takes for each planet to go around the Sun. Let's go through that again. 88 days for Mercury, 225 days for Venus, 365 days for Earth, 687 days for Mars, 12 years for Jupiter, 29.5 years for Saturn, 84 years for Uranus, and 165 years for Neptune. How about these numbers? 0.4, 0.7, 1.0, 1.5, 5.2, 9.5, 19, and 30. Those are the average distances of each planet from the Sun in astronomical units. Which planet is the largest planet? Jupiter, while Mercury is the smallest. You can find all of this information summarized on Podcast 66, Planet Facts. Next week, I'll discuss asteroids and comets in zodiacal light, all of which are part of our solar system. Most people are familiar with the Big Dipper, a group of 7 stars that makes up the larger constellation called Ursa Major, the Big Bear. Our 2 featured deep sky objects this week are near that Dipper, and we will use one of the pointer stars of the Dipper to find them. They are the planetary nebula M97 and the galaxy M108. A finder chart is Podcast 66, Map 4. Both objects are visible in small telescopes. Large binoculars under dark sky conditions may pull in these 2 objects too. M97 is known as the Owl Nebula because under good conditions it looks like an owl's head and the owl is looking at you. 2 dark spaces on either side of the middle of the Owl Nebula look like dark eyes staring back. The Owl Nebula has low surface brightness, meaning the light is spread out over an area of about 6 arc minutes across. In the old days, the nebula was listed at 12th magnitude, but it's actually much brighter at about 9.7. Having said that, in light-polluted environments, it can be difficult to pick up. The Owl Nebula, M97, is about 1,600 light-years away. Nearby is another Messier object, M108. It is a galaxy that is 45 million light-years away. Shining at magnitude 9.4 and measuring 7 by 2 arc minutes, it stands out as a nearly edge-on galaxy. Now for fun with the marathon. The Messier Marathon is a challenge to see all or nearly all of the 110 galaxies, clusters, and nebula cataloged by Charles Messier more than 200 years ago. The Messier objects are some of the best objects in the sky. Each year in late March, it is possible to see all 110 objects in one night from mid-northern latitudes. This year we had a bright moon in late March, but now the moon is leaving the sky In the night of Saturday night, April 10th, Sunday morning, April 11th, is a good time to try the Messe Marathon. Let's begin first in the evening sky. The sun is moving north, so in the northern hemisphere, from mid-northern latitudes, the sky is getting dark about 20 minutes later than it was 20 days ago. During those additional 20 minutes, objects in the western sky will be 4 times lower by the time it gets dark. And in the past 20 days, as the Earth moves around the sun and our sky perspective changes, objects move about 15 to 20 degrees closer to the western horizon, and some have already set by time the sky darkens enough for observation. As a result, we will not see some of our favorite objects in the western sky. M74 will have already set, so too for M77. M33 is very low in the sky and probably not visible. So those 3 objects will be missed, giving the maximum number visible at 107 Messier objects. That is expected for this time of year. Meanwhile, M31, M32, and M110 are now more easily visible in the morning sky than in the evening sky. And the same for M52. And you might as well look for M103 in the morning sky too. Other than that, the search sequence is similar to the one we use in late March. In the morning sky, your last 3 objects, M72, M73, and M30, should all be easily visible before morning twilight. So there you have it, the mid-April Messe Marathon. 107 objects possible from mid-northern latitudes. To recap the podcast, what's up this coming week? The moon goes from our morning to our evening sky, being in new phase on Monday, April 12th. Comet Atlas is in the morning sky, and look for M97 and M108 up near the bowl of the Big Dipper in your telescope. And memorize a few facts about the planets. Take 1 planet a day, and I'll see you next week. You have been listening to Looking Up with Don, podcast episode number 66 for April 7th, 2021. I'm Don Mockles. Once again, the related website for this podcast is donmacholtz.com. That is spelled DonMachholz.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky, and in our astro class, we will learn about comets and asteroids. We'll look at a couple more objects in our evening sky, and the moon makes a close passage past Mars. And we will prepare for the second major meteor shower of the year. All that and more. Thank you for listening. See the sky this week. I'll see you next week.